All right, this is Vectors Day 3. This is all on word problems. So I'm going to be going step by step and actually giving you the directions of what to do for each of these type of word problems. And this is also going to be like this on the test. All right, so let's take a look at the first one. A ball is thrown with an initial speed of 25 miles per hour in a direction that makes an angle of 30 degrees with the positive x-axis. Find the component form of the vector. So we're going to be doing those same formulas that we did. We're going to figure out A first. And don't forget to figure out component form for A. We're taking the cosine of the angle and multiplying it by its magnitude. So for this one here, what do you think would be the magnitude? It would be the speed is the magnitude. The angle is 30, so I'm doing cosine 30 in the calculator and multiplying it by 25, and I get it to be 21.7. We'll do the same thing for B, sine of the angle times the magnitude. Again, angle is 30, sine of 30, timesing it by the magnitude, 25, and I get that to be 12.5. So in component form, I could write it with the A first, comma, the B, or I could have it as 21.7I plus 12.5J. Another example, two forces of magnitude 40 newtons, this is an expression of force in physics, and another force of 60 newtons are acting on an object at angles of 30 and 45 degrees with the positive x-axis. Find the direction and magnitude of the resultant force. So we have two things being pulled at an object of certain angles with certain newtons of force. So I have everything listed here of what you need to do. Okay, so the finding A and B for force 1. Force 1 is going to be the 40 newtons of the force at the 30-degree angle. So this is going to be my magnitude here, and this is going to be my angle, 30. So I'm going to be using that A and the B formula. Okay, so for force 1, the magnitude times the cosine of the angle, 40 times cosine 30. Also for B, 40 times sine 30. This is my A and B for force 1. Force 2, is the 60 degrees newtons. That's my magnitude. And my angle for that one is negative 45 degrees. I'm going to be doing the same concept again, finding A and B for force 2. Okay, so when I plug in my 60 degrees times cosine negative 45 and 60 degrees times sine negative 45, I get my force 2 component to be that 42.4 comma negative 42.4. Number 3 says I have to add F1 and F2 together. I get it to be about 80 newtons there. Then to find the direction angle of this F1 plus F2, so the direction angle formula is inverse tangent of B over A. So my B is that negative 22.4 over the A. I'm going to plug that into the calculator, and I get the direction angle to be negative 16.2 degrees. So that means the force, the resultant force, is being pulled by 80 newtons in a direction of negative 16.2 degrees from the positive x-axis. All right, so we're going to learn how to sketch bearing angles. So we have our north, south, right, east and west. Some of you know by never eat soggy waffles. So I want to sketch an angle that's north, 30 degrees east. So I'm going up north, but 30 degrees towards the east. So going straight up north, but then 30 degrees east. My 30 degrees is going to be here. And then the angle that's left in respect to the positive x-axis would be 60. The next one here, south, 55 degrees west. Let's make our never eat soggy waffles. So we're going down south, but towards the west of 55 degrees. So the 55 degrees is going to go here. And what's left out of the 90 is 35 degrees there. All right, this is going to be helpful when we start doing these airplane problems. So we're going to do two together here. So here we have an airplane, has an airspeed of 500 kilometers. and it's going bearing north 45 degrees east. The wind velocity is 60 kilometers in the direction of north 30 degrees west. Find the magnitude and direction of the plane. You want to always use the angles with the positive x-axis. So this is the most important thing here. So we're going to sketch this first. So we have the wind going to affect this plane, and we want to see what the resultant vector is. So the plane is going 500 kilometers. That's the magnitude. North 45 degrees east. So north, I do this in blue, but 45 degrees east. This is my plane. 45 degrees here, so it's also 45 degrees here. This is the angle that I want to use in my problem, always with the positive x-axis. That's the positive x-axis. Then I have wind that's affecting the plane, 60 kilometers, in the direction north, 30 degrees west. So north, but then 30 degrees west. This is the wind in green, 30 degrees west. Oh, I did that wrong. It should be west. Now I have to erase. All right, so here it is correctly, north 30 degrees west in green. So again, I want the angle with the positive x-axis. So what is this big angle with the positive x-axis? Well, I got 90 degrees here in that quadrant, plus another 30. So that's going to give me 120 degrees for the wind. Okay, so we're going to first do the airspeed for the plane. So I'm going to be taking my magnitude, 500, cosine, 45 degrees, and 500 sine of 45 degrees for each of these. I'm going to be plugging these in. So for the first one here, I get 354. And this one as 354 also. So this is written as 354, comma, 354. For B, for the wind, I'm going to be taking my 60 and being multiplying it by cosine 120. 60 times sine 120. Multiply those two out, and I get it to be negative 30i, negative 30. You can put the I if you want. And this is 52J. So this is for the plane and the wind here. Negative 30, comma, 52. All right, now I have to add those two together. Okay, so when I add it together, I get it to be 324 and 406. Now I have to get the magnitude. So I'm going to use that formula, square root. When I plug that in, the speed as a result of the wind affecting it is 519 kilometers per hour. And then to get the direction angle, which is E, tangent to the negative 1, B over A, so the B is 406, the A is 324. I plug that in, and the angle is 51.4 degrees. All right, so the angle again was 51.4 degrees, and the magnitude of the plane is 519 kilometers per hour. All right, let's do a second example. See if you could sketch these two things on the with the bearing angles. An airplane has an airspeed of 600 kilometers per hour, and it has a bearing of south 20 degrees east. The wind velocity, so that's the wind, is 40 kilometers per hour in the direction south 45 degrees east. Find the magnitude and direction of the plane. So go ahead, pause the video, see if you could sketch these two with the correct angle measurements. Okay, so here are the two angles, south 30 degrees east and then south 45 degrees east. If you notice here, I'm using the angle again with the positive x-axis. So I'm using the angle that's going down from the east towards that 30, which would be a negative angle. So it'd be negative 60 degrees. And the same thing For the wind, I'm using that angle from the positive x-axis down to where it is, which would be negative 45 degrees. Okay, so when I do my formula, my magnitude times the cosine of the angle was 300. Magnitude times the sine of the angle is negative 520. So the airspeed vector for the plane there is 300 comma negative 520. Now I'm going to do the same thing for the wind. Okay, when I plug it in, 40 magnitude of the wind times cosine of negative 45 degrees is 28. 40 times the sine of negative 45 degrees is negative 28. So the vector for the wind is 28 comma negative 28. Now I'm going to add those two together. And I get that to be 328 comma negative 548. Now I'm going to find the magnitude of that. So when I do the formula, I get it to be about 639 kilometers per hour is the speed of the plane after the wind affects it. And the direction angle, I'm going to use that formula, inverse tangent of B over A. That comes out to be in the direction of negative 59 degrees there. So here is my speed of the plane as a result of the wind. And here's my direction angle as a result of the wind.